Thought today I'd do a little video on the 74-193 binary up-down counter. I was playing with this a little while ago, and I just wanted it to count up to 15, count down, count back up again, and I thought I could use the carry out and the borrow out outputs, but it wasn't as easy as that. It appears that they only change state after you reach the count of 15 for the carry out, or the borrow out after you reach 0, like on the next pulse. So anyway, I played with that for quite a while, and I just thought I would show you guys what I found. So it does work. I did get it to count up, count down. See, it's counting down to 0, and then it counts up to 15. Counts down, counts up. And I was able to do this with, well, I got a 555 timer for my clock here. That's the 193 there. Then there's, I had to use a few NAND gates, 7400. And I used flip-flop, 74LS76. And just a 74 LS20, I guess, right? And a hex inverter, 7404, I think. So, and for dramatic effect, I ran the output to a 74 154, which I can fire up here maybe. So yeah, just show you that it does count up and count down. So I drew it up. I'll talk a little bit about the schematic. So for the clock, it's nothing fancy. As you can see, it's just a 555 timer. I wanted to keep the duty cycle to around 50%, so the capacitor charges through both resistors and discharges through RB. So if you keep RA pretty small in comparison to RB, you can get pretty close to a 50% duty cycle. So yeah, you can use, these are the values I used here, and it got me from using a 1 microfarad cap about 6 hertz to 64 hertz, and a 10 microfarad cap, like a little under 1 hertz to 6.4 hertz, I guess, or whatever. And so, yeah, that was the little timer circuit. It might be useful. So this is the pretty simple little circuit that was used to do this. Like I said, it's a 193 counter. Pin 4 is up, pin 5 is down. You just have to make sure you switch the clock up and down to do that. So you take the data output and the complement of the data output into a pair of 4 input NAND gates. That's a 7420, 74LS20. And it either a count of 15 or a count of 0 these are ordinarily going to be high at the output, and either count of 0 or 15, this will go low. The output of this NAND gate will then go high, and the output from here then goes from a high to a low transition, which triggers the flip-flop, and then the output and the complement of the output are gated with the clock so that you get either which one is that's the up, so that's the up clock signal, and that's the down clock signal. So pretty straightforward. I was going to try to use the borrow out and the carry out. Just didn't work out. Like I said, I think earlier, that they only change state on the next clock pulse after you reach 15 or you reach 0. So there might be a way of doing it. I don't know. Originally, I wanted to cascade these and make it count up to 31 and back down again. But I need the breadboard for something else, so this is as far as I'm going to take it. Yeah, hope this is useful for someone out there that's wanting to use this for some kind of application.